to Miss B makes it easier. It's been a while. Now let's get started with atomic structure. The behavior of matter suggests that it is made up of very small particles. These particles may be atoms, combinations of atoms such as molecules, or electrically charged species called ions. An atom is the smallest particle of an element that can exist and still have the properties of an element. The word atom is derived from the Greek word atomos, meaning indivisible. Atoms have diameters of about 10 to the negative 10 meters, which is pretty small. They are made up of electrons, protons, and neutrons. These are sometimes called subatomic particles. Below is a table visually depicting the relative masses and charges of the subatomic particles: electron, proton, and neutron. Those are the subatomic particles. And so we have here the mass of a proton. The mass of a proton is 1. Its relative charge is positive 1. And its notation is 11p. And proton is found within the nucleus of an atom. A neutron is also found within the nucleus of an atom. It has a relative mass of 1. It doesn't have any charge. And its notation is 1, 0, n. An electron, on the other hand, doesn't have a mass. Its mass is negligible. It has a mass, but it's so small that we discount it and we just put it as 0. Its relative charge is negative 1, and its notation is 0, 1, e. And this subatomic particle is found outside the nucleus of the atom. The number of protons in the nucleus of an atom is called the atomic number or the proton number. They are used interchangeably, those words, atomic number and proton number. The atoms of the elements are arranged in order of their atomic number or proton number. The periodic table is a display of the arrangement of all of the elements known in order of their atomic number. Electrons can be found in electron shells. A maximum of 2 electrons can hold in the first energy shell, or energy level. 8 electrons can hold in the second energy level. 18 electrons, 8 and 10, can hold in the second energy level. Each energy level moves further and further away from the nucleus. Energy levels increase as proton count increases. So here's an example of what I'm talking about. And yes, I finally got my board. So here you have the nucleus. So we say this is the nucleus in here. And in the nucleus can hold protons and neutrons. That is what's in the nucleus. Okay? Then you have your first energy level, or where electrons are. The first energy level can hold 2 electrons. So here we have 2 electrons. Okay, so if you are dealing with an atom that has only 2 electrons inside of it, the electrons will occupy only the first energy level, which is the first ring right outside of the nucleus. Okay? And then as you move along, the rings move further and further away from the nucleus. And because the neutrons inside the nucleus have no charge, but the protons have a positive charge, it makes the nucleus very positive, right? And the electrons are negative, and so the electrons will be attracted to the positive charge of the nucleus. As you go further, the electrons are further away from the nucleus. And the second shell can hold a maximum of 8 electrons. And how we do it? We do it in the 12 o'clock, the 3 o'clock, the 6 o'clock, and the 9 o'clock positions when you are displaying your electrons. And this is not how they are in real life. They're all over the place. But for our own sanity, we make them a visual representation at 12, 3, 6, and 9. It's easier. And so you just keep going. And that will make our 8. So 2 and 8. And as you go further, you will see that you will have more shells. And again, it will be 18, so it will be 8, then 10. But do note that at high school level, you don't go any further than the third shell, well, the fourth shell. We don't go any further than that. And also, by the time you come out of high school, you won't be learning it like this. You'll be learning it more on an orbital level of SPDF when you go into higher education. But for now, this is our high school representation of the subatomic particles existing within an atom. Okay? So this is your nucleus right here. I'm going to rub this out so that you realize that the only 2 particles inside of the nucleus is the protons and the neutrons. So I'm going to label nucleus, and these are our orbitals right here. Orbitals. Okay? So if you had an atom with 2 in here and 8 out here, that will make 10. That will make 10 subatomic particles, or electrons, and this would be representing the atom neon. But we'll learn more about that as we go along. So each shell can only accommodate a certain number of electrons. The following table gives information about how many electrons are present within each electron shell. The arrangement of electrons in an atom is called the electronic configuration. So, in the first shell you have 2, in the second shell you have a maximum of 8, in the third shell you would have 18, and the fourth shell you would have 32. 8, then 10, and then 14. So, with electronic configuration in a neutral atom, the number of electrons equals the number of protons. That means the atom wouldn't have been involved in any kind of reaction. The electron arrangement or configuration to an atom is reduced by adding electrons one at a time to the shells. For example, carbon has 6 protons, so therefore it has 6 electrons. And that's the neutral atom of carbon. The electronic configuration of carbon is 2,6. So let's do that. So we're dealing with carbon, and we've just learned that the number of electrons that carbon has is 6. Okay? I'm gonna write carbon up here. We're dealing with carbon, and we found out that it has 6 electrons in its neutral state. So the first shell we know holds how many? You are correct, it holds only 2, a maximum of 2. Okay? So we've already taken care of 2 electrons. So we can minus 2 electrons from here, and we can see that we are left back with 4 electrons. So in the next shell, we know that it can hold a maximum of 8. So therefore, we have 4 more electrons left, and that's enough. That's just enough to put in here because it has the second shell holds a maximum of 8 electrons. So we haven't surpassed the maximum limit. And we're gonna 12 o'clock, 3 o'clock, 6 o'clock, and the 9 o'clock position. So don't forget how to carry them out. So the electronic configurations, we go from the count from the first shell that is occupied with electrons. So our first shell has in 2 electrons, and our second shell has in 1, 2, 3, 4 electrons. And I have something wrong on my thing. So it's supposed to be 2, 4. So 1, 2, 3, 4, 5, 6. So the amount of numbers tell us that this is in the second period, which you're going to learn later on. So just make a note of it. And the last number here tells us that the atom carbon is in group 4. So we're going to get there. Okay? So let me just make a correction. Sometimes, you make a little mistake. Alright, so it's 2, 4. Now it's saying here to determine, it says determine the electronic configuration for the first 20 elements. Carbon is already done for you. So you will do the first 20 elements and you let me know. I will help you out with hydrogen and then helium, and then you could go from there. So if you look at something called a periodic table, you realize that you go from left to right when you're reading. So let's start with hydrogen. I'm going to help you out and then you do the rest. So hydrogen, you would find, has 1 electron. So therefore, if you have hydrogen, 1 electron, then 1 proton, because the electrons will match the protons once it has not reacted with anything. And then we would have here the electron. Remember this shell, the first shell, can hold a maximum of 2, and only 1 electron hydrogen has. So therefore, we will just put 1. And it has 0 neutrons. Okay? Now let's try helium. Helium has 2 electrons. And so if you draw it here, helium has 2 protons. You wouldn't know how many neutrons it has yet because I haven't taught you that yet. But since the mass number of helium is 4, you just subtract 2 from the mass number to get the neutron count, which is 2 neutrons. And you know that the first electron level, or the first energy level, can hold a maximum of 2 electrons. So it's only 2, so therefore you just put the 2. And you keep going. Let me know how that goes. I'll probably post the answers at the end of the video. Right. So, if an atom has 7 electrons, what do you think will be the electronic configuration? Draw this atom's electron shells and state how many protons, electrons, and neutrons are present. Well, I haven't taught you neutrons yet. I haven't taught you mass number yet, so we're going to just ignore the neutron part and we're going to just go right ahead. So we have an unknown atom with 7 electrons. So therefore we know it would have 7 protons. And we're going to just ignore the neutrons right now because that question wouldn't relate to you and it didn't even give you the mass number. Right? So that's a fault on my part. So, alright, so it has 7 electrons. So this is the atom. Atom has 7 electrons. So therefore we know if it has 7 electrons, it will have 7 protons. And since we weren't given a mass number, we're going to just leave that blank for neutrons. And we're going to work with what we have. So, we have here, in the first shell, okay, so it has 7 electrons, so therefore it would have 7 protons. So we know the first shell holds 2, so we put minus 2 right here, and that leaves 5 electrons. So therefore we know in the second shell holds a maximum of 8, correct? So therefore 5 can go in there, so the 1, 2, 3, 4, 5. Yay! So that would be our setup, and the electronic configuration, which is what they asked for, will be how much is in the first shell, which is 2, and how much is in the second shell, which is 5. And so we know that this atom is in period 2, period 2, and it's in group 5. Period 2 because you have two numbers, and group 5 because the last number is a 5. Okay? So here we have, it says try to complete the following table. And we have element oxygen, atomic number 8, and number of electrons is going to be 8, correct? So let me come out and go back in. So the number of electrons is going to be 8. So if you came up with the number 8, that's good. And then the electronic configuration, how do you find that? Well, you know the first shell holds 2. And then you just minus that 2 from 8, and that leaves 6, which is less than 8, which is how much the second shell can hold. So we have 2, 6. In this one, the number, the neon, atomic, if the number of electrons is 10, then the atomic number is 10. And so to work out the electronic configuration, 2, that's the first one. And so 2 from 10 will leave 8, and that's the maximum number it can hold. And then with this one, the atomic number is 13, so the number of electrons is 13. First number is 2, the next number is 8, 8 plus 2 is 10, 10 from 13 leaves what? 3. Good, so you get 2, 6, 2, 8, and then 2, 8, 3. Good job, guys. I'm going to exit this now. Take out these answers because we're going to need it for class. Here, here, and here. And now you know how to work out these things, okay? Good job, girls. Okay, so now we're on to electron shells, energy levels. It says try arranging the electrons of the oxygen atom. It has 8 electrons, 8 protons, and 8 neutrons. The shells are drawn for you using X to denote an electron. By the way, you can use dots, you can use circles too, but X is alright. Can you try to determine oxygen's electronic configuration? So this is something we would have done earlier, but we just didn't do the shell configuration, we didn't show the shells. So the rules of filling shells with electrons are as follows. Pretty much the same thing I said earlier. Fill the shell before adding electrons to the next shell. Each shell can accommodate the maximum number of electrons as depicted in the table earlier. Right? So remember, the first shell can only hold 2, the second shell a maximum of 8, third shell a maximum of 18, but it starts with 8, then you have to go on to 10, and go on and on and on, right? So we're going to do oxygen. And we know oxygen has, it says 8 protons, 8 electrons, 8 neutrons. So here we have oxygen, and we're going to put, it has 8 electrons. Okay? We're going to draw our nucleus with 8 protons and 8 neutrons. So therefore, if it has 8 protons and 8 neutrons, its mass number is 16 because you just add the protons and the neutrons. Protons plus neutrons equal to mass number. Okay? And we're going to learn that coming on further. So remember, the first shell holds a maximum of 2. And if you need help, you just minus as you go along, and you're left back with 6 electrons. Okay? You're left back with 6 electrons. Okay? And so, the next shell, because it has a maximum of 8 electrons, you just go and fill in the 6. You go 1, 2, 3, 4, 5, 6. And that is pretty cool, isn't it? So now you're going to do the electronic configuration, which is 2.1, 2, 3, 4, 5, 6. So we know that it's in period 2 because we have 2 numbers, and it's in group what? Correct, it's in group 6. Good job. And that's pretty much how you do that part. So counting subatomic particles. Atoms of each element have their own symbol to distinguish the element from others. Below is a list of some popular elements with their symbols. We have sodium, Na, potassium, K, magnesium, Mg, calcium, Ca, iron, Fe, platinum, Pt. Now you see how I have a capital letter and then a common letter. You have to write it exactly like that. You cannot come out and say, oh, I'm going to write sodium however I see fit. No. Those are symbols that were made up before you were born and before I was born. Now I've been living for a good while now. So since you know sodium is Na, you cannot, you can, but you should not do this. I'm going to write in cursive and do all sorts of things. No, if your teacher gives you correct, it's because they pity you the math and they really want to see you straight. But if your teacher tells you to write it like how they write it, they really mean it, because that is how it's represented on the periodic table. So don't write in cursive, don't join them up and do things like this. Oh, I'm going to write this and that. No, 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 0%. Alright, so write it how it's supposed to be written, just like how it is given in the periodic table. Okay? So elements like sodium, potassium, iron, silver, copper, gold, mercury, and lead all have symbols indicative of their Latin names. So here we have sodium. The Latin name for sodium is natrium, and that is where you have the symbol Na. Potassium, its Latin name is kalium. That's where you have the symbol K. That's why these symbols don't match their English names, because they kept their Latin symbols. And so iron, which is known as ferrum, is Fe, copper, cuprum, Cu, silver, argentum, Ag, gold, aurum, Au, mercury, hydragium, see I can, hydragium, Hg, and then lead, plumum, Pb. Okay, so write them as is. Mercury is named after the planet Mercury, and its symbol Hg is from its Latin name hydragium, meaning quicksilver, because that's the only metal at that exists as a liquid at room temperature. You know, vanadium, I think, does that too, but that's after you hold it in your hand. Yeah, but the most common one is mercury. So mercury is the only metal that is liquid at room temperature. Okay, so I'm going to end the lesson right here for this part, and see you around next time for counting subatomic particles, moving along further. And thanks for having me, and I hope you enjoyed the lessons I would have given you using my new board. I am happy about it, and I hope you are happy too. See you in probably a day or 2 days to learn about counting subatomic particles and other stuff. Okay? Bye.